Today we are going to be looking at solving linear inequalities. Mine is going to start on page 8. Okay. So one rule that we need to remember from Algebra 1 is that when you solve for inequalities, you are making sure that anytime you multiply or divide by a negative number, you must flip the inequality symbol. We're going to take a look at two basic examples today. The first example is going to be taking a look at a two-step problem where we are going to look at what happens to the inequality. So our problem is x divided by 6 plus 2 is greater than negative 1. The first thing we want to do is we want to subtract 2 from both sides. After we do that, we simplify and we get x divided by 6 is greater than negative 3. Now we want to isolate this x, so we want to multiply by 6 on both sides. Now I'm multiplying by a positive 6, so I don't need to flip my inequality symbol. So when I multiply, I get x is greater than negative 18. When you are solving this, it's always good to go back and check. So in order to check, we want to pick something that is bigger than negative 18. So we're going to let x equal negative 12. We plug it into the original problem. So negative 12 divided by 6 plus 2. We want to check to make sure it's greater than negative 1. Well, negative 12 divided by 6 is negative 2, and negative 2 plus 2 is 0, which is in fact greater than negative 1. Our second example we're going to look at today is negative 7 plus 8 is less than or equal to 1. When you're solving this, again, you use the inverse operation. So negative 8, or subtract 8 from both sides, gives us negative 7x is less than or equal to negative 7. Because this is a negative, we are going to divide by a negative, which means we need to flip our inequality symbol from a less than or equal to a greater than or equal to. And now to check our solution, we'll pick something greater than or equal to 1. I chose 2. We plug it into the original problem. So negative 7 times 2 plus 8, and we want to check to make sure that it is less than or equal to 1. Well, negative 7 times 2 is negative 14, and negative 14 plus 8 is negative 6, which is less than 1. So these are basic examples that we're looking at in order to solve. Now going to flip my paper to page 9. Remember, you can pause at any time to catch up. So here in example 3, I've added a little difficulty by adding in the parentheses, so we have to distribute the 4 inside the problem. So 4 times x and 4 times 3, which is 12. Now we are going to subtract 12 from both sides. So 4x is greater than negative 36. And we're going to divide by a positive 4, so we don't need to flip the inequality symbol. And x needs to be greater than negative 9. I picked something greater than negative 9 to check. I picked 0. 0 is bigger than any negative number. So when I plug it in, I solve the 0 plus 3, which is 3. And 4 times 3 is 12, and 12 is in fact greater than negative 24. Example number 4 adds a little bit more difficulty because I'm adding a term to the left side here. This term doesn't move. This negative 2 gets distributed and multiplied inside the parentheses. So this becomes a 7x minus 2x plus 8, because negative 2 times negative 4 is positive 8, is less than or equal to negative 2. Notice that I have boxes around the 7x and the negative 2x. That's because they are like terms, so I'm going to combine those to give me 5x plus 8 is less than or equal to negative 2. Now we have a two-step problem. We are going to subtract 8 from both sides and get 5x is less than or equal to negative 10. We're going to divide both sides by 5, and x is less than or equal to -2. To check this, I would pick any number less than or equal to -2, and I would plug it back into the original problem to check. Okay, now we're going to step up our examples again to some more complicated examples. This time we're going to have variables on both sides. So we have 6x plus 1 is less than 9 minus 2x. I want to bring the x's to the same side. So I'm going to do the inverse operation to bring this minus 2x over. So I'm going to add 2x to both sides. So that leaves me with 8x plus 1 is less than 9. It's a two-step problem, so I'm going to subtract 1 from both sides. 8x is less than 8. Divide both sides by 8. It's positive, so nothing happens to the inequality sign. So x is less than 1. And our last example that we're going to do today is the most challenging because not only do I have variables on both sides, but I also have parentheses on both sides, which means I'm going to have to distribute twice. I'm going to distribute this -3 to the x and the 6, and I'm going to distribute the minus sign to the x and the -7. So I have the 5x that comes down, minus 3x minus 18 is greater than or equal to 8 minus x plus 7. You'll notice that I have boxes on both sides. These are like terms and these are like terms. So I'm going to combine them together. So I have 2x minus 18 is greater than or equal to 15 minus x. I want to bring my x's to the same side, so I'm going to add the x to make them positive. So I have 3x minus 18 is greater than or equal to -15. Add 18 to both sides. So 3x is greater than or equal to 33. Divide by 3, and we have that x is greater than or equal to 11. Remember that we're going to get some extra practice with this during class.